Hello everybody, welcome back. We have today 7.6 solving radical equations, so let's get to it. Alright, so our daily questions kind of kickstart us off and lead us into the material for today. 2x squared minus 7 equals 25. It says solve the following equations. This is a quadratic. I'm going to add 7 over. 2x squared equals 32. I can divide both sides by 2. X squared equals 16. Is squared an even power? Yes, it is. So when I square it, square root both sides, I get plus or minus 4. Please remember to take the plus or minus, okay? And you do this for all even powered roots. Okay? Awesome. Over here, I got to get this x minus 3, the quantity cubed by itself. How do I move that plus 1 over? Subtract it. Okay, good. Divide both sides by 4. 27. I can cube root left. I can cube root right. Ladies and gentlemen, is this even or odd? This is odd, therefore I'm not going to need plus or minus. I just get 3. Guys, please use your chart, right, which we got the other day. Add 3 over, x equals 6. Okay. This leads right into what we're doing today. Things to remember. Isolate the radical expressions before raising each side of an equation to the same power. If you raise an expression to a power with an even denominator, you must include plus or minus. And check your solutions. Okay, so the same rules apply as before. We're just doing with higher order. Okay, like, so on and so forth. Like 4th root, 5th root, so on. Okay. Number 1, the 4th root of a minus 12 equals negative 10. I'm going to add 12 over. I get the 4th root of a equals 2. What's the opposite of taking the 4th root of something? Well, it's raising something to the 4th power. Okay? So, what we can do here is 2 times 2 times 2 times 2, 16. Now, notice that what I did here, I raised it to the power of 4. I did not take the 4th root of it. Therefore, I'm not doing plus or minus. Okay? Because if you did plus or minus here, just think about this with me. What's the 4th root of negative 16? Your 2i. We don't want that. Okay? So just keep that in mind. Alright. This is the same idea as up top here. I'm trying to isolate this cubed root. So I'm going to subtract 6 over 10. Cubed root 2x minus 1 equals 40. I can divide both sides by 10. Cubed root 2x minus 1 equals 4. Alright. What's the opposite of cube rooting something? Raising it to the 3rd power. Alright. This cancels this out. I'm left with 2x minus 1. 4 to the 3rd power gives me 64. I can add 1 over. I can divide by 2. 32.5. Okay? Guys, real quick, before I go any further, please, at this point, when you're watching this video, if you guys don't get what I'm doing here, just pop up to my desk real quick and I'll explain it to you. All I'm saying is, you have to know that there's inverse operations. So the 4th root of a, to get rid of the 4th root, I raise to the 4th power. To get rid of the 5th root of a, I have to raise it to the 5th power. To get rid of the 6th root of a, I have to raise it to the 6th power. That's all I'm doing. Okay, it's just they're opposite each other. Because really what you're doing here is, I'm rewriting this as 1 over 5 from the 5th root, and then the raise to the 5th power, these cancel out and back to 1. Okay, that's where that comes from. So please take a moment, come on up if that's confusing you. Alright, 3b to the 3 halves, that just scared the life out of me, the door just shut. Okay, 3b to the 3 halves equals 375. I'm dividing both sides by 3. Guys, I'm always getting my variable by itself first. b to the 3 halves equals 125. Alright, this is the first problem you're going to encounter here that's different. Alright, what's the reciprocal of 3 halves? It is 2 over 3. So I'm going to raise both sides to the 2 over 3 power. You are allowed to do this. Look what happens on the left-hand side. 3 over 2 times 2 over 3, they cancel out. I get just b. Now, remember I said about the plus or minusing up here? When I do something like this, you always check your bottom number, because that's your root power. Is this even or odd? It's odd. Therefore, I don't need plus or minus. But look what's going on here. This turns into the cubed root of 125 squared. Alright, what's the cubed root of 125? 5 squared, which then is 25. So you see how I'm going about this. You go the reciprocal. So in this case, and that's really hard to read, the reciprocal was 2/3, raise both sides to 2/3 power. Bottom number is always your root power. Okay? Top one's your exponent. And then just solve it like you normally would. Alright? Use your chart if need be. Number 4. 5c to the negative 2/3 plus 11 equals 31. Getting this by itself. Same routine every time. Subtract 11, subtract 11. 5c to the negative 2/3 equals 20. Divide both sides by 5. Alright, I'm going for the reciprocal here. Negative 3 over 2. Negative 3 over 2. These cancel out. Is the bottom number even or odd? Hopefully you guys are cool with that being even. That means I do need plus or minus here. Okay. Question for you. What does a negative exponent do? It flips. So I have 1 over the square root of 4 cubed. And when I flip it down in the denominator, that negative becomes positive. Okay. Square root of 4 is 2. 2 cubed is 8. Plus or minus 1 over 8. Alright. Always check the bottom number. Here it was odd, there it is even. If it's even, it's plus or minus. Okay? Again, I really want you guys to be familiar with, x to the 1/2 power equals the square root of x. Something that I want you to know at the end of this unit. Okay? Alright, on to the back. Doing good. Bunch of problems here. We'll see how many we get done. Okay? I'll try maybe to break this up into 2 videos. But, alright. Number 5. Square root of 2x plus 4 minus square root of 3x equals 0. Okay, there's a trick to this one. I want to get rid of the square roots. Okay, so what I'm going to do is I'm going to add this square root of 3x over. So I get the square root of 2x plus 4 equals the square root of 3x. Alright, there's 2 ways of looking at this. One, they're both under the square roots. So what I need to have happen here is just everything underneath this square root has to equal everything underneath the square root over there. You could also just square both sides. If I square both sides, it cancels out the square roots, and look what I'm left with. Ooh. X equals 4. Or, I guess it looks nicer this way. Right? And you could check yourself too if you really want to, which these problems is nice. 8 plus 4 is root 12, minus 3 times 4 is 12, so root 12 equals 0. Okay, over here, number 6. I already have it going for me, which is nice. So I can square left, I can square right, get rid of the square roots. Okay. Easy enough. These are the nice problems, even though they look deceiving. I can add x over. Negative 5 equals 2x. Divide by 2 on both sides. X equals negative 5 halves, or negative 2.5. I'd encourage you to start writing answers like this, like improper fractions. Again, we're getting awfully close to pre-calc, so I'm really going to try to bear down the next few months and show you guys tricks to get you ready for pre-calc. Okay, 7 and 8 begin to get more difficult. Okay, and you'll see why in a minute. But take a look at number 7. I have the square root of 3y equals y minus 6. All right. Now, I want to get rid of the square root. correct? So I can square this left side. Here's the dilemma. I need to square the right side as well. Well, what's this become? Well, I have to square it, which means I'm foiling it. You can't just go y squared minus 36. I have to square the whole thing. Okay, so that means I have to FOIL. Just a quick recap in foiling. Y times y is y squared. Y times negative 6 is negative 6y. Negative 6 times y is negative 6y. Negative 6 and negative 6 is positive 36. These can combine together. There we go. There's my trinomial that's formed. So on the left-hand side, I get just 3y. Yay! On the right-hand side, I get all this junk. Ooh. Okay, so now I got to subtract 3y over. 0 equals y squared minus 15y plus 36. Alright, and guess what? It's a factoring problem. I know I mentioned this before, but I really didn't mean it. Factoring is one of those things that it's just going to keep popping up throughout your rest of your mathematical career. It really is. If you plan on taking this class, oh yeah, you plan on taking this class, pre-calc or whatever, you're going to need it. Okay, what numbers multiply to give you 36 but after negative 15? Okay, well we got 1 and 36, 2 and 18, 3 and 12, 3 and 12, winner winner. Negative 3, negative 12, sweet. Y minus 3, y minus 12, I got lucky because it was leading coefficient of 1. I can set both of these equal to 0. All's good. Okay. Now there is something that I'd like to, this is probably going to be the last problem I'm going to do for this video. So I got this answer, right? Which is all well and good. One of the things I want to do is I just want to check on something, okay? And the reason I'm doing this is, can you see on the left-hand side I have square root and the right I don't? If I plug a 12 in, 3 times 12 is 36, the square root of 36 is 6. 12 minus 6 is 6. 6 equals 6, I'm all good. But this one, look what happens. If I plug a 3 in up top, I get square root of 9. If I plug a 3 on the right, I get 3 minus 6. What's the square root of 9? 3. 3 minus 6 is negative 3. Does this make sense to you? I'm hoping that you guys agree that it's not. This is called an extraneous solution. So what we do is we put an X through it and we write the word extraneous. This is important, okay? There are two answers that work, okay? I'm doing work, okay? But when you plug it back into the original problem, there's going to be times when they don't make sense. This is going to be a common trend over the course of the next few chapters, like this one, and especially chapter 8 when we start working with logarithms. So you want to make it a common trend. Now, again, I didn't do it up top here because when you plug these both in there, you can see like I have square roots on both sides. It's going to be okay. I encourage you, even if you have the time, to go back and do it there as well, right? Extraneous solutions is a big thing that's going to be coming up a lot more, and we're going to see a fair amount of it, okay? So I'm going to end right here. We still have 8, 9, 10, and then a few word problems to go through, and these are some really good word problems. I'll see if I can get this video made up before whenever, but if you have any questions, please feel free to ask. All right, and as always, keep up the good work and good luck. We're all counting on you.